Now that we've learned about conditional probabilities, we can learn the general multiplication rule, which works all of the time when we're dealing with multiplying probabilities. So the general multiplication rule is building on this multiplication rule that we learned previously. So the multiplication rule before, when we had two events occurring, and again the and tells us that two events were occurring, we simply multiplied those probabilities together. Example, when we were flipping a coin, that would be 50% of the time we get tails, so 0.5 times 0.5, and that gives me 0.25. Now, what happens when the trials are not independent? So here's what that means. Each time I flip a coin, I have the same chance of getting heads or the same chance of getting tails. If I have something that's not independent, for instance, I've got marbles in a bag or cards in a deck, etc., and I take a marble or a card out of that, that means what's left over is now less than before, and therefore the probability is different. So in that case, we're doing the probability of A, the first event, and then the probability of B, given that A already occurred. So this works all the time because the probability of B given A already occurred for an independent event is really just the probability of B, so it doesn't change. Let's take a look at what I mean here. If I have 10 marbles in a bag, 3 orange, 2 black, 4 yellow, and a red, and I want to find the probability of a red and a black, that means I'm finding first the probability that I get a red. Well, out of my 10 marbles, one of those 10 marbles is a red, so 1 out of 10. Now, if it was just red and black and they were independent, then I would say then times 2 out of 10. Except the problem is there's no longer 10 marbles in my bag because I have taken that red marble out, and now what's left over? Only 9 marbles. So using this general multiplication rule formula, I'm taking 1/10 times 2/9. That's how many black out of how many total marbles given that I've taken the red marble out of the bag. So 2/9, and then I would multiply and then of course find it as a decimal. So let's do a few more practice. In this case, both examples, we're going to use a deck of cards and we're going to be without replacement. And without replacement essentially just means that once I take the card out, I don't put it back in the deck before I draw the next one. So in this case, we're going to find the probability of selecting 2 kings. In statistics, we of course would write that as the probability of king, and meaning that there's 2 events. And using that general multiplication rule, I'm going to find the probability of a king times the probability of a king given that I've already taken a king out of the deck. So the probability of a king would be that there are 4 kings out of 52 cards. And yes, I get the question a lot, well, can't I just write that 1 out of 13? You of course can do that. I'm just keeping it out of 52 so that we know there's 4 kings out of 52 total cards. Now the second time, there are not 52 cards, there are only 51 cards because I've already taken a king out of the deck. And there are not 4 kings left, now there's only 3 because I already have a king that I've pulled out of the deck. So these are the numbers that I would then use. So 452 times 3 over 51. Again, we can reduce a little bit, so 1 out of 13 here, 1 out of 17 here. When I multiply, I get 1 over 121, and then I turn that into a decimal. Same thing for selecting a 2 and a jack. Again, the way that we would write that is 2 and jack, and then we're finding the probability that we get a 2 times the probability that we get a jack, given that we've already taken a 2 out of the deck. The first one is 4 out of 52, which is the same as before. The second one is 4 out of 51 because there are still 4 jacks left in the deck. I didn't take one out, but there are still 51 cards because I've taken out that 2. Again, do some reduction and multiplication, and then we end up at 0.0060, which I just wrote as 0.006. Here's another scenario for you. There is a committee of 7 people, 4 women and 3 men, and the committee will randomly select 2 people to attend a conference in Hawaii out of those 7 people. I would like for you to find the probability that both of these selected people are women, and then find the probability that both are men, and then press play to check your work. So again, the first one is probability of woman and woman. There are 7 people total, 4 of them are women. We're going to assume that we have now found that a woman to go, which means there's only 3 women left to choose from out of 6 total people left. I would multiply and reduce, and then I would find that answer as a decimal. The second one, that both are men, is going to look very similar to this, except that the 3 starts out on top because there's only 3 men to begin with, so 3 out of 7 and then 2 out of 6. Again, multiplying and turning that into a decimal, I get 0.1429. So there's essentially a 28.6% chance that both are women, there's a 14.3% chance that both are men, and of course the rest would be that there's 1 man and 1 woman.